Hello, everyone. Once again, thank you so much for your time. Today, I'm going to continue our discussion on EMC consideration. Okay, today's video is actually a follow-up on the previous video. In the previous video, I actually shared the photo of the essential test and measurement equipment required for radiated emission and radiated immunity. So please go through that video before you actually come to this video. The previous video link I have included under the description. So please see the video before you come to this video. Okay, so today our topic for discussion is understand radiated emission, okay, which is also known as RE, and radiated immunity, RI, test and measurement procedure. This is my email. If you have any question regards on today's discussion, please drop me an email. Before I continue, I'd like to urge you guys to support this channel by like and subscribe. So please don't hesitate to press the like and subscribe button. Thank you so much for your support, guys. Okay, so this diagram here shows the test and measurement for RE, radiated emission. This is the device that you want to test. Okay, it is also known as EUT, equipment under test, or DUT, device under test. Okay, this device is actually rests on this non-conductive table. Okay, so this non-conductive table is approximately 0.8 meter. And this table is actually housed on a turntable. So this turntable will rotate 360 degrees. 3 meters away from the turntable is actually the antenna. Okay, so this antenna is supported by an antenna mast, and it will be able to hoist up the antenna up and down from 1 meter to 4 meters. Okay, the antenna is actually connected to a EMI receiver. Okay, the EMI receiver actually measures the field strength that captured from the antenna. After it captures the data, it's actually routed to a PC. The PC will determine whether your device compliant to the EMC test and measurement or not. Okay, so what is the key thing that we actually need to do for RE? Okay, for RE, we actually want to measure how much electromagnetic wave is released by your DUT. So let's say this device that you actually want to do some testing, it releases the electromagnetic wave. Okay, it's actually measured by this antenna. The antenna will feed the data to an EMI receiver, and then after that, they actually feed the data to a computer. So the computer will do some calculations, some analytics. Okay, from there, it actually quickly determine whether your device compliant to the EMC test and measurement or not. Okay, so let's go through the procedure, how we actually conduct the radiated emission test and measurement. Okay, the equipment to be tested, EUT or DUT, is placed on a non-conductive table of height approximately 0.8 meter. We sit on a rotatable turntable. Okay, so this is what I told you earlier on. This is a device that you want to test. It actually rests on this non-conductive table, okay, which is about 0.8 meter tall. And this whole thing is also sit on a turntable. So turntable will rotate 360 degrees. Okay, a tripod is used to support the antenna, which is connected to an EMI receiver to measure the radiated emission from the EUT. Okay, so this side here, 3 meters away from the turntable, is actually the antenna mast. The antenna mast is linked to a EMI receiver. So the antenna actually will be capturing all the electromagnetic wave that is released from the DUT. Okay, the emission from each phase of the EUT are measured by moving the measuring antenna up and down from 1 to 4 meters. Okay, both horizontal and vertical polarization are measured. So this antenna will move from 1 meter to 4 meters. Okay, and then both the horizontal and vertical polarization are measured, and the data is again fed to this EMI receiver. Okay, the field strength in dB microvolt per meter is captured by the EMI receiver at frequency typically from 9 kHz to 6 GHz. Okay, the measured field strength is then compared to the limit line of 6/22. Okay, if the measured field strength is less than the limit line of 6/22, the EUT has passed the radiated emission test. Okay, so take a look on this data that we actually measure for a customer. So you can actually see that there are two sets of data. One is for the horizontal polarization, and now another one is for the vertical polarization. Okay, so this actually depends on the antenna orientation, okay, whether is it vertical or horizontal. This is a limit line. So like what I have shared with you earlier on, in order to comply the EMC test, all the point must be underneath the limit line. Any point that exceed the limit line, you need to further troubleshoot on your DUT or EUT before you undergo another round of EMC test and measurement again. Okay, next, I'm going to share with you on RI. Okay, so this part is also quite similar with radiated emission. Your EUT or DUT housed on a non-conductive table, which also on a turntable. On the other side is actually the antenna. Okay, now the antenna is actually fixed at 1.5 meter, which I'm going to share with you later on. Okay, so inside the shield room or control room is actually where the amplifier is. The signal generator generate the RF signal. Okay, the RF signal is actually pulsed up by the amplifier. Okay, so they become quite a strong signal, and the antenna actually release the electromagnetic wave to disturb your DUT. And later on from the camera, you actually see whether your DUT perform satisfactory or not. Okay, if it does not perform in a satisfactory manner, it means that you fail the EMC test and measurement of RI. Okay, for example, your EUT may do a reset, okay, or it will have some form of degradation of performance. Okay, so it actually based on several conditions. Okay, so let's go through the test and measurement procedure. Okay, the equipment to be tested is placed on a non-conductive table of height approximate 0.8 meter with seat on a turntable. Okay, so this is exactly what I have mentioned with you earlier on. Okay, a tripod is used to support the antenna, which is connected to a signal source and power amplifier to generate the radiated field strength of 10 volt per meter. Okay, on the AM modulate, it becomes 18 volt per meter to the EUT. Okay, which means that the signal generator actually generates the RF signal. Okay, it actually passes to amplifier. So the amplifier amplified the signal to ensure that 10 volt per meter actually hit the DUT or EUT. Okay, the antenna radiates the field strength at a fixed height of 1.5 meter for both horizontal and vertical polarization. Okay, the EUT is observed for any malfunction in operation by a CCTV camera. Okay, the operating frequency is typically from 80 MHz to 6 GHz. Okay, if no malfunction is observed, the EUT or DUT has passed the radiated immunity test. Okay, so like I told you, you actually generate a very high electromagnetic wave to disturb your DUT. And from the camera, okay, you observe whether the device passed the test or not. Okay, if the device is found to operate in a satisfactory manner, okay, this means that they actually compliant the radiated immunity test. Okay, with this, I'd like to end my discussion. Okay, please like and subscribe. Thank you so much, guys.